So our next factor is temperature, and I want us to consider this common equation. This is an equation famously that we learned about. They have a process combining hydrogen gas with nitrogen gas to give us ammonia. So of course, we know that this equation or this reaction is an exothermic. The forward reaction is an exothermic. That's why the enthalpy change is negative here. It has a negative value there, meaning that reaction progresses or produces heat as it progresses. Of course, if the forward reaction is exothermic, then the backward reaction should be the opposite, should be an endothermic reaction. So generally, if a reaction is an exothermic reaction, then increase in temperature does not favor that reaction, because remember the equation, the reaction is producing heat. So adding more heat is adding stress to the reaction. So the opposite is true. So for a forward reaction, if you want to the forward reaction, which is exothermic, to proceed on, then you need to lower the temperature. So by lowering the temperature, you are reducing the stress. The opposite is true for an endothermic reaction. Endothermic reaction, we know that's a reaction that absorbs heat from the atmosphere. So if you added heat or you raised the temperature, then you will favor that reaction. So for our case here, if we are interested in ammonia, that is the forward reaction, then we need to lower the temperature. If we increase the temperature, then our reaction, the forward reaction, will not be favored. And so if the position of the equilibrium was at the center, and then we raise the temperature, then the forward reaction will not be favored, and so the position of the equilibrium will shift towards the left. So in order for us to favor the forward reaction, then we must lower the temperature, because the reaction is exothermic. Consider another equation here. I want us to consider this equation of dinitrogen oxide N2O4, which is a gas. It normally decomposes to give us nitrogen 4 oxide, and this reaction is endothermic. That's why the enthalpy change is positive. Actually, it's 57 kilojoules per mole. So if we are interested in forming nitrogen 4 oxide, which requires the forward reaction, then because the reaction is endothermic, then increasing the temperature will favor the forward reaction. So if the position of the equilibrium was at the center, then raising the temperature will cause a shift of the position of the equilibrium towards the right. So it will favor the formation of nitrogen 4 oxide. Actually, nitrogen 4 oxide is a brown gas, and this one is colorless. So we're going to see the brown color intensity increasing. Next, we're going to look at pressure. So, however, something we need to note before we go to the pressure, we need to note that a change in temperature or temperature has no effect if the overall enthalpy change of the equation is 0. So if the enthalpy change of a certain reaction is 0, there is no change, then a change in temperature will have no effect on that reaction. So next I want us to look at pressure. So how does pressure affect the position of the equilibrium? So of course we say the pressure will affect those reactions that involve gases, production of gases, or in which the reactants are gases. For instance, in our case here, we are using hydrogen gas and nitrogen gas to form the ammonia gas. So remember, in the factors that, as we were looking at the factors that affect the rate of a reaction, we said pressure has the same effect with that of concentration. So when you increase pressure on gases, in short, it's like you are increasing their concentration. So how will pressure affect the position of our equilibrium here? So it's simple. You only need to check how many moles of gases do we have on the reactant side and how many moles of gases do we have on the product side. Like in this case, here I have 3 moles, so I have 3 moles, and here I have 1 mole, so 3 plus 1, that is 4 moles. On the reactant side, I have 4 moles, but on the product side, I have 2 moles. I have 2 moles. So when I increase pressure in this system, then because the reactants are more, we can use the word bulk, they are more, their volume is larger than that of the product, then pressure, increasing pressure will increase the concentration of the reactants more because they are bulky, and so it's going to favor the forward reaction because here we have 4 moles but here we have 2 moles. Increasing pressure will compress these 2 gases, these 4 moles, and so they're going to react to give us the ammonia. Consider this equation where we are decomposing phosphorus 5 chloride. So here we have 1 mole, this is a gas, sorry, 1 mole, but on the product side we have 1 plus 1, so we have 2 moles. So increasing the pressure in this system will not favor the forward reaction because the products they are bulky, they are more bulky than the reactants. So increasing the pressure will favor the backward reaction, and so the equilibrium will shift towards the left. Consider this other equation here. Here we have 1 mole plus this 1 mole, so in short we have 2 moles. And also on the products we have 2 moles. Now here the moles on both sides are equal. So increasing the pressure or reducing the pressure will have no effect on the position of the equilibrium. Thank you.